Cool. Let's hop back on to the next thing that we're going to talk about, which I think is a reason why a lot of folks are here. Servers, APIs. How do we do the thing in Node? Like, show us the promised land. Okay, this is it. I want to save this one to close to last because obviously there's a lot of stuff you need to know before you can take advantage of it. So we are going to talk about servers and how you could build servers in Node and the many different ways you can do it, and then pretty much my recommended way. But we won't be going into detail how to build like some ridiculously nice CRUD API that talks to databases and stuff like that, because we already have courses for that on Front-End Masters that I highly recommend you check out after this course if you're really interested in how to build a modern API in Node.js today. So check those out if you're interested. But this course, in this section, we will be talking about at least the fundamentals behind it, how you could do it natively, and how you should do it with something else. So Node.js has access to OS level functionality like networking tools. So when you're starting a server on a machine, whether it's your computer, whether it's Amazon somewhere, whatever machine it's on, it's accessing the network tools exposed from the operating system to whatever language you're working with. So in this case, it's exposing it to like C++, which is exposing it to JavaScript through, in this case, something called the HTTP module. So we're actually interacting with the operating system through Node. And I think that's just really interesting if you think about it. Like you're literally talking to the operating system through JavaScript. And if that's just not powerful, I don't know what, especially seeing where JavaScript started as like, changing colors of hyperlinks and things like that. Like it's just crazy to think that you can do that now. But yeah, so it has access to stuff like that. And that's why a lot of people use Node, because like it is JavaScript, right? But it does have access to the OS level things, but also because when it comes to like APIs and stuff, Node is, and I talked about this a little bit, it's single threaded. And if you don't really know what a thread is, you can think of a thread as like, it's like a block. So if you have a CPU with 8 cores, right, you could think of like one thread taking up 1 core. So you can do like 8 different things at once if you took up all 8 cores. Whereas JavaScript will only ever take up one of those cores, one of those threads, and it won't, it basically uses an event loop, which has like a different worker thread separate from the thread that your code is working on. And it will schedule different things, and it will just keep looping over and over to see if some work needs to be done. And when that work is done, it'll basically notify you when it's done with like a callback, which can be translated to a promise, which can be translated to async await. And that's where all that stuff comes from. So this basically allows us to continue receiving requests from our users and our customers at the same time we're scheduling more work to be done and processed in the background. Whereas other languages, it's blocking. So you might have requests coming in and they're being processed in kind of like a serial manner. That doesn't mean they're slow. They're not slow. They just are blocking. They have to have access to multiple threads. The other thing is Node can have access to multiple threads. Just by default, it doesn't. But you could use the, I forgot the name of the module. I want to say it's the OS module, maybe the core module. I can't remember. They changed it. I could look it up. But you can use that module, or even a third-party modules probably are better than using the internal one, to actually spawn different amounts of work into different threads, which is perfect for something like load balancing when you're deploying a server somewhere. So you can access multiple threads. Just by default, it won't do that for you. It's a manual thing that you have to set up, and you have to manage that yourself. It is not managed internally via Node like other languages are. So just keep in mind of that. That was a lot, but I needed to get that out. So let's talk about servers now that we know why servers are good in Node. Node does ship an HTTP module, like I said. It's an abstraction around OS level networking tools. But even, some people might laugh when they hear this, but HTTP module is low level. And I know the reason I say some people might laugh because it's like literally nothing in Node is low level compared to other languages. But compared to other stuff in Node, yes, the HTTP module is very low level, and you should probably never use it. I can't think of any good example why you would ever use the HTTP module, but I'm going to show you how to make a server using it, not because I want you to, it's because I want you to see the difference between using this versus installing something and how better it is to leverage something from the community versus doing something from scratch. So what we're going to do is we're going to build this HTTP server here from scratch. So let's do that. I'm going to make a new, let me get rid of this thing. Go I'm gonna make a new folder here. We're gonna call this server. And I'm gonna make a index.mjs. And I'm going to import HTTP from HTTP. This is included in Node, so I don't have to install anything. We're good to go. And if you were to look at that, you'll see that there's just a bunch of stuff on there, networking things, like stuff you would pretty much never use, but that's why I said it's pretty much low level. So you can follow along with me, or you can copy and paste this code here, but I'm going to walk through it so we can kind of see how it goes. So the first thing is we need to just make some variables here. I'm going to make one for the host, which is going to be localhost. If you don't know what localhost is, it's your machine. It's a reference to the IP address of your machine, which is usually something like 127.0.0.1. That's pretty much the IP to your local machine, but you can reference it as localhost. The local DNS lookup on your computer understands that localhost points to that address that I just put, that IP address. So localhost is great. The next thing we want is a port. If you don't know what a port is, you can think of a port as like the doorway to your host. It's like, how do you get to the host? Most websites that are deployed on the internet have a host of like 8080 or like 8000, mostly 8080 or 80. It's just that the browsers don't show them, but they're there. They're all there. You just don't see them because they all have the same port, so why even show it? They just exclude it from the URL, but it's definitely there. But locally, we have to specify a port. So you can think of it as like every time you make a server on your local host on your machine, you need to put each one on its own port, because a port can only be occupied by one server, not many. So if you try to start another server on the same port, you'll get an error saying like, this is already being used, try something else. And then sometimes you'll have different programs on your computer that open up ports without you knowing. So if you download, I don't know, some taskbar app up here, it's probably using a port on your computer and you don't even realize it, like Dropbox Sync or Spotify, who knows? It could be using a port and you might not know until later. So most time ports are like 4 numbers, sometimes they're 5, but we're gonna use 8000 for now. Sometimes you'll see 3000 and things like that. We'll just use 8000. And then the next thing is we're gonna create a server. And that is, we can say HTTP.create server like this. And it takes in a callback function, which is going to be the handler. Like, how do you handle the incoming request from the server? So we're going to say, okay. And then that callback receives 2 arguments. The first one is going to be the incoming request. I'm just going to put rec for short. And the next one is going to be the outgoing response. I'm going to put response for short. Because the way servers work is that they handle requests and then they respond to them. That's why I guess that's why they're called servers. I don't know if they modeled the name after restaurants or whatever, but it's a server. It serves the clients. So you receive a request and then you respond to it in the fastest way you can. So we have our request and response here. And then the next thing we want to do, if you think about a server, there's typically different paths. So if you ever went to a URL like somewebsite.com/something, and you go to /somewhere else, it shows you 2 different things. You get 2 different pieces of data, whether it's a website or an API. Those are 2 different paths. But you also have different verbs. So you might have the same path to like /to-do, but one might be a post and one might be a get. So you can think of a route on the server as a combination of a path and a verb, and that would be a route. So you can have many routes on your server. So what we're gonna do is we're gonna create some routes and do different functionality depending on what those routes are, and we'll try to figure it out from there. So what we'll say is if request dot, what is it? Path, see, I don't remember. Now I gotta look, oh, method, there we go. So request.method is a post. So if someone's doing a post request here, that means they're trying to send some server to the data. We wanna grab that data and we wanna like put it somewhere. So let's do that. First, let's like create like a little, I don't know, database, I guess, of things. No, actually, no, we won't. We'll do that on the next one. So we'll say post. And then what we need to do is, because this is like very raw, and even if you send JSON up, we're not going to receive it as JSON. We're going to receive it as like a buffer. Like when we were reading the file and it was all those little bits, that's how we're going to receive the data. That's not very useful for us. So we need to, and it's not going to come at once, right? It's being streamed to us in little bits. So we have to collect all of them and then put them together, and then we'll have the data that the user intended to see it, the client intended to send us. So we need to do that. We need to collect that. So I'm going to say body equals like a string. Then I need to register some events on the request object that fire whenever a new piece of data comes in, and I need to send that data over to the body to be collected, which we could then look at. So I'm going to say request.on data, and this is going to get a what we call a chunk, literally a chunk of data. And I'm going to say body plus equals that chunk. So we got that. The next thing I'm going to do is say rec.on close. So when it's done, there's no more data coming in. We should be good to go. I am going to, this is where you would like insert into a database, right? Like, oh, we got the data, we're good to go. We can insert into the database. I'm just going to log this so we can see what it is. So we'll say body. So if it's a post, we'll see that. And then else, if it's not a post, if it's just a GET request, then we will just do a res, or I'm sorry, actually before the GET request, we need to close this response. Yeah, I was about to run into a big mistake. If you don't respond back to the client, your server is going to be hanging, as in it's going to be stuck in this state of like, I received the request, but I don't know what to do with it. And then the connection is going to be stuck open, and the client's going to be like, I'm waiting, you know, to hear back from you. You haven't gotten back to me yet. And then depending on the client, whether it's a browser or whatever, there's a certain timeout limit. Eventually it'll just time out. So if you ever seen like a timeout error, it could have been someone who forgot to send back a response, or more probably what actually really happens with the response is just taking too long. But sometimes, yeah, somebody probably just forgot to respond back. And that's what would happen here if I would have moved on. So we do need to close off this branch here by responding. So I'm just going to say the quickest way is to do like rest.end, and then you can send back like something like that. But I'm also just going to say rest.set header, or no, I want to say set, no, which one do I want to do? Set a write head, is it? I think it's write head. Yeah, I want to do a write head. So this is like writing the header, the status code. So for a successful post, it's usually a 201 status code. If you don't know much about status codes, it's totally fine. You can look them up whatever you want. But in today's world, especially with like GraphQL, status codes are becoming less and less of a thing. But it is very helpful to understand the different status codes. Probably will take you 20 minutes just to read them and figure them out. But a 200 status code means successful. Get 201 means successful post. So we're going to do a 201. And then else, if you didn't post, you just did a regular get, we'll just say rest.end, and it will say hi, like that. And I'll also just say rest.write head 200 for a successful get, like that. So now we have our server. The next thing we need to do is we need to listen for the server. We have to turn it on to the actual ports and stuff like that. So we'll say server.listen, and you can see here it takes a port. We have a port. It takes a host. We have a host. And then the last thing we could do is we could put a callback here to do something, and then we'll just say console.log server on, and then let's do some template strings here. We'll say host port. There we go. So we'll try that, and if I didn't mess anything up, we will see this server run. So let's give it a try. So I can say node, and where did I put this? Server index. So I can say node, server. Oh, I got to back out. There we go. Actually, I'm just going to go into that file. So that folder, there we go. And then I can say node index, index.js. And as you can see, we are on localhost 8000. So that log worked. It's logging server on localhost 8000. And notice my node app is still running. Up until this point, we would run a command, it would execute, and then it would stop, and it would exit, and we'd be back in the terminal. Right now, it's just sitting here, it's just waiting. Because we're connected, we as far as nodes understanding is, there's still some work to be done. There's still some work to be processed. So it's just continuing along and waiting. And that's the difference between like a server and like a CLI, where we ran one command and it was done. Or when we did the file reading, we ran one command and it was done. A server just stays on. That's the whole point. So unless you're doing something like serverless, which is like something that doesn't stay on, but still operates in the server context, you probably want your servers on all the time. So that's what this is doing. It's just sitting here until it errors out, or when we stop it manually, which you could do with Control-C. So I'm going to keep that running. And then now I'm going to interact with this API to see how it works.